sample ballot. All right, quadratic and linear systems. All right, a system. System is where there's more than one equation. You're looking for where they intersect. Before we get into the details of finding the intersection, let's think big picture for a minute here. What do quadratics look like if we were to graph them? A U, a parabola. And I don't even know how to ask what a linear thing looks like because it looks like a line. So how else do you? I don't know. It looks like a line. We'll be looking for where they intersect. So before we start this, though, let's think about the possibilities that could happen if we're looking for the intersection of a parabola and a line. Options or possibilities. So there's a parabola. And when I mean options or possibilities, like how many times might a line intersect that parabola? Okay, might be twice. So you might have two answers. But are there other possibilities? How would it intersect once? Okay, vertex, yes, but it wouldn't have to be the vertex. It could be somewhere other than the vertex, as long as it looks something like that. So yes, the vertex is sort of an obvious spot where if it was a x equals or a y equals line, it could be the vertex. But it doesn't have to be the vertex. If it's tangent to the graph, kind of a fancy word, then it intersects once. Ryan?
But wouldn't that line keep going and intersect again?
No. I mean, well, yes and no. Yes, the parabola keeps going, and yes, the line keeps going. But the parabola is getting steeper and steeper. The line's just headed straight out, so they won't intersect again. Right? Do you see that? I mean, it's a good question, but this parabola is never going to turn, and this line is straight, so it never gets to turn. So they won't intersect again. Any other options for how they might intersect or not intersect? Never. Zero. So before we even get started, we can realize or kind of reason through the options here. We might have 2 points of intersection. We might have 1 point of intersection. We might have no points of intersection. I don't think we could get any more than 2, though. There's just no way with a U and a line to get 3 intersections. Okay, so that's good to know ahead of time. Our answers will always be 2 points, or 1 point, or no point. And it's also good to realize that no solutions is a possible answer and a possible correct answer. Okay, now let's get to some examples here. State if the point given is a solution to the system of equations. So this is like someone solved this, and we want to check their work to see if that's right. So how do I see if that point...
You just plug the X into the X and the line.
Plug it in into which one, the first one or the second one? It's going to have to be both, right? If it matches the first one, that just means it's on the first one. If it matches the second one, that means it's on the second one. So we gotta do both. So let's see, -9 minus 2 times 0 minus 7 times -3 minus 6 equals 0. -9 plus 21 minus 6 equals 0. That's a no. Now, did I do everything right? Let me double check here. -9 plus 21 minus 6. Yeah, I don't know what that is, but it's not 0. Right? I mean, I do know what it is. It's 6, but not 0. So we don't even have to check the other one. That doesn't matter. It's not on the parabola, so it doesn't matter if it's on the first one or not.
The other one first.
The other one was easier. The other one, it does work on the other one, right? Like, that's an easy one to check. So that one's true, but the first one was false, so that's a no-go. If I'm guessing number 2 works just because that's how math teachers like to arrange things, right? Give an example of each. But let's see. So 2 times 25 plus 19 times negative 5. 2 times negative 4 plus 53. What are we doing here? 50 minus 95 minus 8 plus 53 equals 0.
Yes.
I think that does work. Negative 45 minus 8 is negative 53 plus 53. So that one works. Second one should be easier to check, but I've got to check it. Negative 5 minus 2 times negative 4. Negative 5 plus 8 is 3. Yes, that is true. So yes, that point is on both the parabola and the line, so it is a solution to that system of equations. Okay, but that's kind of the easy stuff, like just taking the answer they give us and seeing if it works. Although that is a good reminder that once we get our answer, if we want to check, we just plug it in and make sure it's right. Again, if you checked everything we ever did in here, you'd never finish a test. But if you get to a hard one, or if you got 5 or 10 minutes left at the end of the period, then you can go back and plug in a few and make sure you were on the right track. Number 3, solve each system of equations. Do you remember the method you used to solve when it was linear systems? Elimination or substitution.
Or graphing.
Yeah, or graphing, although I don't think we want to be doing graphing here. But you're right, graphing is, I guess it's still an option. You just have to be able to graph them accurately. But that's too much work. We're not really going to do graphing. Now, elimination versus substitution, when it was lines, usually it was sort of equally good, and elimination was generally preferred, I think. I think substitution is going to be better on this one. It's going to be harder to make something go away when there's squareds and not squared. So I think substitution, they both work, but I think substitution is probably going to be preferred. Unless you could tell right away that like one of them's already set up to, like you remember that on elimination, like sometimes they'd give you 2 equations that were like, I don't have to do anything, I just combine them and something goes away. If that happens, you can still do it. It just doesn't happen as often here. So I think I'm going to work most of these as substitution problems, unless one jumps out as being super easy to use elimination. Okay, so substitution means
If you want to get it,
No, we use this all.
solve for a variable
I just mentioned, where are you?
and then substitute. So solve for a variable, then substitute. In fact, we should solve for a variable in either equation. So you get to pick the equation and pick the variable and what you want to solve for.
I think the second equation.
I definitely think the second equation, right? Because that looks a lot easier than the first equation. Now, do you want to solve for x or for y?
I solved for y.
Well, either one looks pretty simple, so
No, if you solve for x, you only have to plug it into 3x, and not a x squared.
I like that. Just looking at the second equation, solving for either one is equally easy, right? You just subtract it over. But you peek at that first equation, and you're like, it'd be easier to plug in x. So let's solve for x and then plug that in. X equals 2 minus y.
Oh, that's why.
So y squared plus 3 times 2 minus y, because that's what x is. X is 2 minus y. So in place of x goes 2 minus y. Right? That's why it's called substitution. We're substituting 2 minus y in for x. Okay, that's, I think, the hardest part of the problem. Now it's just algebra, 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 algebra. Hope that it factors. Of course, we can handle it if it doesn't. Y squared minus 2y plus 1 equals 0. factors. In fact, it factors kind of nicely. I think that suggests we have one answer rather than two answers. It's kind of a double root. Remember that when you had the repeated factor? We're not really worried about that for that, but I'm pretty sure I'm going to get one answer here. Okay, so y equals 1. And then I can grab this equation and substitute again. X equals 2 minus y. So x equals 2 minus 1. So x equals 1. I want your answer as an ordered pair, though, so don't just leave y equals 1, over here on the page, and x equals 1 is way over somewhere else. Combine those. The solution is 1, 1.
Does that mean it only hits one time?
Correct. That means the only place they intersect is at 1, 1.
So that would be like a tangent one.
So that's probably almost certainly back to our picture. The only way it can intersect just once is if it's a tangent line. So yeah, that line is tangent, this line is tangent to that parabola.
I think it's still.
Oh, you're right. It doesn't have to be a tangent line. It could intersect like that. That's true. Good call. Good call.
Yeah, wait, but wouldn't that intersect later on if it's straight up? Yeah, if it was straight
It would have to be straight up. You're right, man. You guys are on it today. It would have to be x equals, because if it had any angle at all, eventually the parabola would intersect it. So that would have to be an x equals line. That's not what we had. So yeah, it's a tangent line. That's all far beyond what we need to worry about. Number 4. So I need to pick an equation and then pick a variable. So which equation would you like to solve first?
The second one.
That's the easy question. Now, which would you like to solve for?
Solve for y.
I think I'd like to solve for y as well.
Pardon this interruption. Please.
Okay, so I'm solving for y. And then substituting for y. So negative 2x squared plus 24x. Let's be careful with the minus sign here, because I need to subtract all of that.
Don't you split all the signs?
So I substituted 2x minus 2 in for y. All right, gentlemen, I need you guys to substitute. Careful with that minus sign. Negative 2x squared plus 24x minus 2x plus 2 minus 62 equals 0. Fingers crossed that it factors. Negative 2x squared plus 22x minus 60 equals 0. Because it equals 0, we can divide by negative 2 even. Make life a lot easier. So even if it doesn't factor, we've at least got easier numbers to deal with. But that factors. Speaking of factoring, we still need to know how to factor, which is just good news for 95% of you. X minus 5, x minus 6. So x equals 5 and x equals 6. But I've already got a y equals here, so y equals 2 times 5 minus 2. So 10 minus 2 is 8. So one of my points, and this is another good reason to write your points. If you just have x's and y's on the page, it's not clear who goes with who. So 5 comma 8 is one of my answers, if I used x equals 5. If I use x equals 6, 2 times 6 minus 2 would be 10. So 6 comma 10. All right, one more. Which, let's pick on somebody here, because why not? Kennedy, which equation would you like to solve? Would you like to work with first? The first one or the second one? She left. Liam, which equation would you like to work with first?
Number 5.
Which one on number 5? The first one or the second one?
The second one.
Definitely the second one. Cooper, would you like to solve for X or for Y?
Yeah, let's solve for Y.
Why do you pick Y?
Because all the other ones are X and nothing is just Y. I think it's like any equation, right?
I think it's because that other equation only has one Y in it,
Yeah.
and I don't have to worry about square and stuff. So if you pick wisely, it makes the problem a little easier. If you solve this for X, it's going to be uglier, and you're going to have to. It's going to work, but choose wisely. Make life better, as always. Wise choices lead to better results in algebra and in life. 3x squared minus 3x plus 4 times. Okay, here comes my substitution. In for y goes negative 2x plus 3. So 3x squared minus 3x minus 8x plus 12 equals 0. So 3x squared minus 11x plus 12 equals 0. Can't divide by 3, so that doesn't do me any good. I don't know if that factors or not. So it'd have to be 3 and 1. Then I'd be looking for a pencil to start guessing and checking. They would have to both be negative. 3 and 4 wouldn't work either way. 6 and 2 wouldn't work. 12 and 1 would definitely not work. Ugh. Warm up those singing voices. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, this looks bad, but we're going to be able to kind of pull the plug on this thing pretty quick here. Rather than 36 times 4, I'm going to do 12 times 12. I mean, it's the same thing, but I know what 12 times 12 is.
So then what's 121?
What's 121 minus 144?
Negative 23. How does one plug this in?
All right, let's think back to the very first part of this. We varied those 3 pictures we drew at the beginning. We know we're headed for an imaginary type answer here.
Plus or minus means 2 answers, right?
Plus or minus means 2 answers, but think about where they intersect on the real axis.
Yeah, this doesn't exist on there.
This doesn't exist on the real axis.
Are we ever going to have an imaginary axis? Is that a thing?
It is, but it's a simpler thing when we deal with it. It's not an x, not combined with the xy axis. So
it's just kind of
no solution. If you end up with eyes, in fact, you could just put no real solution. It doesn't intersect in the real world. In the imaginary world, maybe, but we're not plugging that in. Figure that out. So, hey, what do you know? We started with saying that there are 3 possibilities, 2 answers, 1 answer, no answer, and we did an example of each of those things. That's how math teachers work, you know. All right, so your assignment is not all of them yet anyway. Friday assignment, that's 1025, is this worksheet 1 through 6.
Oh, yes. Oh, my goodness. That's amazing.
And then you can peek ahead. Monday's assignment is going to be 7 through 12.
That's very hard.
So you already know how to do those. Monday will be kind of a light day. I'll answer a few questions, maybe work some together, but that'll be about it. So fairly easy weekend, and Monday means you could do them all and then not have anything to worry about Monday. Your call. But it's the weekend, it's a football game, it's a pep rally. Let's